Hi, Astronomy. It's Mr. Janowski. Here's the next part of the slides. So the last class we started off, we did the Kahoot and reviewed the stuff we had learned so far. So not a whole lot to say about that other than the questions you'll see on the test often are present on the Kahoots, and they're often present on the quizzes and things like that. So at the end of a chapter, when it's time to review, go back, look at the Kahoots, play the Kahoots by yourself, or interact with people in your own separate meet, things like that, and look at the quizzes too. And then we also watch this YouTube, Why Virgos Have More Car Crashes, and M9, which is Messier Object 9. So the keys, the highlights of that were, one, that there's nothing to astrology. It's not a thing. Professional scientists give absolutely no credence to it. It means nothing. But also, besides that, which was the main reason I showed it, but besides that, in the video, she did also talk about things like the ecliptic and the precession of the Earth's orbit, and what the 12 signs of the zodiac actually mean, and why there should actually be 13 of them, because the sun goes through 13 constellations in the ecliptic, and things like that. And then I told you briefly about this celestial sphere demonstration that we're missing out because we're doing this remotely. So yeah, no more on that. Hopefully we'll get back in person and be able to do this for real in a classroom. So what is the difference between rotating and revolving? The Earth rotates on its axis. So when the globe is spinning, we say the Earth is rotating. And the Earth revolves around the sun. So the Earth making laps around the sun, that is revolving. So that's what those two words mean. They're similar, but make sure you have it clear in your head which one's which. So what is the path the sun appears to trace as it moves through the constellations of the zodiac? That is called the ecliptic. So yeah, it's the apparent path of the sun across the celestial sphere, the 12-ish, 13 signs it goes through. Signs, I'm calling them signs, constellations it goes through. Yeah, that's what the zodiac is. And the ecliptic is also the plane of the Earth's orbit. So the Earth goes around the sun in this pretty constant plane. If you just project that plane out across the celestial sphere, that is also the ecliptic. They mean the exact same thing. So we talked about the seasons and what causes the seasons. So first, the Earth does not orbit the sun in a perfect circle, but rather a particular type of oval called an ellipse. So the Earth's orbit around the sun is an ellipse, but it is so close to being a circle that you almost couldn't tell that it wasn't a perfect circle just by looking at it. So this image we're looking at is highly exaggerated. The Earth's orbit around the sun is much closer to a circle than this. So when the Earth is closest to the sun, so the sun is not actually at the center of the ellipse. It turns out it's at one of the focuses, or foci, of this thing, the ellipse. We'll get to this later when we do Newton's ideas and things like that. When the Earth is closest to the sun, it's about 147 million kilometers away. And that actually happens in January. So when it's furthest from the sun, it's about 152. So yeah, if you look at these numbers, 142 million versus 152 million. Yeah, again, this drawing is definitely not the scale. It's shown to, it exaggerates the scale just so it's clear that it's an ellipse. But yeah, key idea. We're actually closest to the sun in January, which in the northern hemisphere where we live, that's winter. And we're furthest from the sun in July, which is northern summer. So the fact that we have seasons and, it's cold in winter and warm in the summer, it's not because of the varying distance of the Earth from the sun. It has much more to do with what we're going to learn about on the next slide. So yeah, the reason we have the seasons is because the axis on which the Earth rotates is not perpendicular to the plane of the ellipse. So if you look at this drawing here, so here's the plane of the ellipse, the plane of its orbit. So here is, the plane of the Earth's orbit. This line is perpendicular. If we were spinning on this line, we really wouldn't have seasons. Everyone on Earth would always have 12 hours of day, 12 hours of night, and there would be no seasons, or there would be very, very slight seasons, but basically no seasons. But the reason we do have the seasons is because the axis we spin on is actually tilted relative to this line right here. So what that means, right here, this is northern winter. So if we look down here at this drawing here, yeah, in northern winter, the North Pole is tilted a little bit away from the sun, which means the whole northern hemisphere is not getting hit very squarely by the sunlight. So that's why we have winter, because we're getting hit less directly by the sunlight. Um, and the thing about this tilt is that the Earth maintains this same angle off in this direction up to the upper right throughout the entire year, and it maintains it almost perfectly. So, yeah, 3 months later, here we are in March, and we're still pointed off in the same direction up to the upper right. 3 months later, we're over here in June. So, June is northern summer. So, the reason it's warmer in the northern hemisphere in June is because we happen to be leaning, the northern hemisphere is kind of leaning towards the sun a little bit. So the sunlight is going to hit us more directly. But again, notice the axis is still tilted in the same way. 3 months later, here we are, still tilted in the same way. And then 3 months later, yeah, we've made a full lap and we're still tilted in the same way. Now, it's not exactly the same way. It will move very slightly by some fraction of a degree, but it's almost exactly the same way. And it just maintains this orbit, constantly. So another visualization about why it's warmer in the summer than in the winter. So this is, northern summer is what we're looking at here. So first, two beams of light coming from the sun. So these two beams are equal in brightness and intensity and the amount of energy they're carrying towards the Earth. And on the Earth, we're going to look at two separate areas. And these two areas are the same area. I was in trouble as soon as I started that sentence. But yeah, these two areas are the same. So here we are, northern summer. This area is getting hit by exactly one full beam of sunlight at this part of the year. Now, if we go down to the southern hemisphere, that same area is not getting an entire beam of sunlight, all to itself. So it's getting less sunlight. So less sunlight, it's the same amount of energy is being shared over a bigger area. So yeah, it's the heat from the sun will not be as intense here. So this is why, if we go back to the previous slide, that is June. So June in the northern hemisphere is summer. The same exact day in the southern hemisphere, well, it's still June 21st, but in the southern hemisphere, that's the start of winter. And going all the way around, here we are in December 21st, where in the northern hemisphere we're leaning away. So December 21st, yeah, it's usually pretty cold. In the southern hemisphere, so Australia, Brazil, places like that. In the southern hemisphere, December 21st, that's the beginning of the summer in the southern hemisphere. So that's when it's starting to get warmer. So not only is the sun hitting the northern hemisphere more directly in the summer in June, but the days are longer in the summer. So we're getting more sunlight more intensely and for longer. So that's going to increase, the warmth in the north compared to the south. And the sun also rises higher in the sky during the summer than in the winter, which we'll talk about more in the next class. The height of the sun at different times of the year, and the sun's path across the sky at different times of the year at different latitudes. So the seasons are caused by the tilt of the Earth's axis of rotation. That's what causes the seasons, not the fact that we're closer or further from the sun at different times of the year. Although that's true, and that does have a small effect, it's not nearly as big an effect as the tilt of the Earth's axis. So, yeah, that is the reason for the season. And that's as far as we got. So I'd actually planned to get a little bit further with these slides, but I, like you, am new to remote learning. So I'm still figuring out the pacing. So we got this far, and yeah, I'm fine with that. That's cool. I'll figure this stuff out. So hopefully this was helpful.